Record. शुरू करो. Good afternoon, students. Today I am just teaching you on subject modern method of weft insertion. If we see, there are several types of loom in the world, but for apparel and technical purposes, attachment and weft insertion systems are different. Process of weaving always remain same basically, but the procedure of weft insertion is always differs on loom to loom, and it depends upon the type of fabric to be woven on the loom. We have to select. We will discuss the weft insertion system, their advantages and limitations in this presentation. Now, if we say basic motion of looms, so everybody knows shading, picking and bit up. Shading means the bar shade opens to facilitate the weft yarn. Then picking is the mechanism which gives drive to weft yarn into the shade. Then both the barb and weft are bit up by a mechanism called as bit up, and consequently fabric is made in different weaves where we commanded the patterns. Now if we go on depth, basic motion of looms, secondary motion, take-up motion. Take-up motion governs the what fabric woven to be wound on cloth roll. This is a mechanism for keeping the fabric on cloth roll. Then let-off motion is the motion to regulate a warp beam in a uniform tension to facilitate the weaving operations. Now there are some auxiliary motions on the machine. Say warp stop motion. When the warp yarn among the several yarns is broken, the machine will stop by a mechanism called as warp stop motion. Same way, if weft yarn is broken or the bobbin is exhausted, weft package, machine will definitely stop by a mechanism called as weft stop motion. Now in present era and modernization of the methods, looms are equipped with the microprocessor based controls. In modern looms, we are achieving better efficiency and productivity. Productivity means production with quality because of microprocessor informations, and even operator efficiency can be increased by tackling him for any negligence, because what accountability operator is giving in warp time or weft time is recorded in the microprocessor. It takes how much time. The microprocessor based informations are many. Some of them we are just defined here. More bar breakages can be recorded. Suppose there should be 3 breakage per hour, and breakage are coming within the range or beyond the range. We can see, and accordingly machine can be attended. The same way, web breakage rates can be recorded. The same way, stoppage due to mechanical reason, either stops in terms of breakage per hour, then troubleshooter has to find the reason and attend the machine. As I told you, time taken by weaver in piecing, then alarm for due maintenance, lubrication schedule. See, every machine has a fixed maintenance schedule because maintenance is very important part of the process. If our maintenance is not good, even 1 year old machine will not give the result. And if our maintenance is excellent, even 40 years machine will behave like a new. All are new. We are driving the vehicles, car, motorcycle, scooters. If we are taking care time to time, they are with us. And if we are not taking the care of the servicing, oil changes, so we are just stuck on the highways. So everyone knows the importance of maintenance. So no need to tell this. But you see, suppose the frequency of maintenance, say quarterly maintenance required, say 6 monthly maintenance required, say annual maintenance required, say maintenance after 2 years required. So there are different signs and alarms which will just blink on the microprocessor. So one can understand now maintenance due. And after doing maintenance, these alarms will be triggered. Now production evaluation in terms of loom efficiency, woven meters, fixed per insertion, total loom running hours, etc. can be uh, fed in the microprocessor, and they can give the calculations for which formula already there, and control on piece length. Suppose we want 300 meter of fabric, check 300 meter, loom will stop. Unless he will not beaver or we will not reset the machine, loom will not start. The control on piece length by alarming signals, then graphical analysis to control cost of production, various defect occurrences during running loom. There is a lot of analysis we can find from the microprocessor. Even we can take in our PCs, we can record them and study them. What is the response of the viewing? What is happening? What is not happening? If not happening, what to do? If it should remain like this, what to do? So there are a lot of chances for analysis and action for the management on these high productivity looms with microprocessor based controls. Now, beaver changes is possible without mechanical changes. We uh, we can change the fabric pattern or design without mechanically much more involvement. Just we have to operate touch print, and what we wish we have to feed, and machine will take the our wish. Then even speed of the machine means revolution per minute RPM can be changed by the same way. No need for mechanically changing of the pulley, time delay, stoppage of the loom. Just stop the loom, change the frequency of the electric by some touch print, RPM will be changed. Decrease or increase what you want. Same way, fixed per inch can be changed in microprocessor. Then, if something is happening wrong in the machine, suppose relay vibration, some bolt are loose. So because of disturbed synchronization, microprocessor will give the alarm, and cost can be attended, and machine can again be restarted before coming in some critical breakdown. So this is an added advantage of the microprocessor based controls. Now, modern method of Weft Insertion, I am coming on the subject. There are many machines, as I told you. In single phase weaving machine, the four systems are very famous all over the world, and machines are being used. Projectile Technology, then Rapier Flexible Retread Technology, then Water Technology, then Airjet Technology. In Projectile Technology, Weft insertion is possible by a series of projectiles, small projectiles, which I will tell you in the mechanism in next slides. In Rapier technology, there are two grippers. One is giving the yarn to receiver, and it goes to the other side of the weave shed, and beating takes place. This is a very economic weaving system, and adopted very much for technical fabrics as well as even aesthetic property fabrics, because any type of count can run on the system. Here if you see water jet looms, the weft is inserted by the jet of water, treated water. Then air jet technology, here weft is inserted in the shade by the jet of air, quality air, compressed air. Now if we compare these four technologies of weft insertion, we can see in about two, projectile and rapier, there is a solid thing which carries the weft into the shade. And same way we see the below two technologies, water jet technology and air jet technology, nothing is solid to take the weft into the shade. If we continue the modern method of weft insertion in multiphase weaving technology, then multi-axial weaving technology, then weaving machines and embroidery unit, then needle weaving technology for narrow fabrics and ropes, then 3D weaving. Now we'll go in the depth of these technologies. First was the projectile weaving machine, cylinder projectile weaving machine. These machines were very much in use and in market all over the world, and they are very good mechanically for making quality fabrics. And all type of fabrics can be worn on this machine. They are very versatile. But they are Swiss machine actually. But Lacuna was dead. Microprocessor was not there. In present era, soldiers are less, and higher technology has come. No doubt, soldier also applied the microprocessor, but cost is very high of the machine. People are going on the other technologies. But this machine is still used for the technical textiles. If we see projectile technology go in the mechanism of the weft insertions, there are several models of the machine according to the suitability of the particular yarn. Suppose label shows P750, B190, N2, EP, T1. So P represents the projectile, 7150 is the loom series or loom type, B stands for cotton, 190 is the width of the machine, nominal width, N2 means two color machine with two weft insertion system, EP means shading by tappet, basic shading. The D1 is equal to a small projectile with steel, a small cross section projectile with steel material. Now if we say PU, then F. So PU means projectile universe, again projectile and type of series. Then if we say F means suitable for filament. If we say 230 means loom with this nominal machine of the width is 230 centimeter. We say N4 means suitable for 4-color weft insertion. We say SP means Dobby is there for more design properties. Then D2 means steel projectile with big cross section. So that way around 18 models comes in the soldier in the market. Now if we go on the mechanism, picking takes place by the series of projectile. This projectile carries the weft yarn from left hand side, called as SU side in language of the Swiss, and other side is called as the FA, right hand side, in the language of the Switzerland. So weft runs from left to right and reed beats up and consequently fabric produced. The weft is directly drawn from a large package with or without accumulator to facilitate unwinding of the yarn. Now I am telling you the projectiles. So these are the projectile. These two are the projectile. The small projectile of steel having certain dimension. We will show in the next slide. And if you see this projectile, we open. There is a gripper which holds the yarn. This is the body, and this is a riveting unit. And this one is the brake. If projectile is triggered very high with a very high speed in the shade, the brake is responsible for stopping it as and when required. Now, these are some more picking parts. We can say that this guide. This guide has a role. If projectiles are traveling in a shade at a high speed, 300 rpm or 450 rpm, so projectile should not escape and somebody will injure. They are passing through these guides actually, and they are not touching it. Otherwise, abrasion will take place. Settings are so sophisticated. Without touching these, projectiles are going from this number of guide parts. I show in the next slide. This is a picking shoe, which gives the motion to the projectile. This is the picking lever, which operates the picking shoe. This is the feeder. By this mechanism, something push here came, it opens, takes the weft, then the pushing comes other side and it closes actually. So this weft yarn inserted for weaving. Now, as I told you, projectile, its dimension is steel projectile 90 mm long, 40 mm wide, and 6 mm thick. It carries the weft thread into the warshed. Then here is an interesting thing. Both the extremities of the fabric, the selvages. You see, if we are taking some pen piece, there is a thick portion on the fabric both sides called as selvage. So this taking selvage, suppose we are taking a yarn, so on the extremities it loops like this and beat up takes place. So what happens? The density of the selvage is double than the fabric on the body, which gives the compact fabric, which is good for the polish and processing. Now, if we see how picking takes place, so there is a torsion rod, which is running a picking lever like this for picking. So when this layer comes in rest position, then it tights like this, like this, like this, and just triggered. So projectile goes in the shade. That way, suppose 300 rpm. So in 1 minute, 300 times the cycle takes place. So this lever is operated by a torsion bar, very sophisticated torsion bar. So for 300 rpm, example, this torsion bar will twist or untwist 300 times. So this is the heart of the machine, soldier machine. Now, as I told you, safety is very important. So these are the guide teeth. A projectile travel from these guide teeth without touching any metal to metal. Otherwise, spark will take place or they may break. So alignment is there, settings are there. So after doing setting, weaving is very smooth. Now soldier multiple split. See, there is a trend of the splits in the weaving, because within the same running time of machine, we can make one width or we can make several widths, subject to what fabric we have to make as well as cost, what we can afford. There are machines available in 73 inches or 190 centimeter, then 130 inches, then 153 inches, then 210 inches, etc. For good utilization of the width, suppose on 153 inches machine, we make just 73 inches fabric, it's not economic. But if we put 73, two widths together, with the same weaving cycle, we'll get the double production. So we would prefer, even we can take a symmetrical width also. For 150 centimeter, we can take one fabric of 50 inches and one fabric of 99 inches that way. The symmetrical and asymmetrical fabric to utilize for width of the machine is possible here. Now, after this projectile weaving machine, we are coming to Rapier looms. The Rapier system of weaving, Weft Insertion, first invented by Max Pavo in 1958, and it is very good for the mass production in the weaving. This Rapier looms, actually we can say there are two grippers. One gives the weft yarn, other takes the weft yarn in the shade. And there are two types. One is flexible and one is rigid. Suppose we have to make the light fabrics like shooting, like sari, like dress material, or any bed sheets, any aesthetic fabric. We have to choose the flexible Rapier machine. Even they take more floor space. For strong fabrics or heavy fabrics like technical textiles, there are two big rods in which this Rapier goes, and these are rigid Rapier machines which can take high moment to the weft insertion system. So selection of machine depends upon the what fabric we want to make. Some fabrics are accommodated on the flexible as well as rigid Rapier loom as per demand of the market. There are more versatile machines. These are the Rapier tabs which operates the Rapier, and these are the Rapiers which I told you. Now, this is the Smith loom manufactured in Italy, and these are very good for the shawl weaving and blanket weaving. In shawl fabric of ladies wear, we can see there are very longer patterns of 5,000 and 7,000 pattern repeats of designs. So initially in conventional weaving, people are doing 2-3 days for just putting the design to the loom. Now, thanks to microprocessor based control, here is a provision of touch screen. One can make 5,000 fixed design in 1 hour only or 2 hours only, depends upon the practice. And even if there is a small fault inside in the fabric during checking, one can just correct it within few minutes. While conventional weaving, it was not possible, again time taking work. Same way in the blanket. Now we have the provision of the tappet for plain fabrics, then dobby for designs. The many dobbies are coming: story dobbies, KR2, KR1, KT dobby, then Promatech. Many dobbies are coming. Then jacquard. Jacquard is mostly coming for the more elevated figure on the fabric. So these are the jacquard loop mounted on the top of the machine. They are single cylinder, single lift jacquard, or double cylinder, double lift jacquard, like this. These are the mechanisms of the jacquard, making the very elaborated figures of the fabric and designs. The technical textiles, if we say it is a 12 segment, and this is coming industrially fast in the market. People are enjoying very good USP by running some specific fabrics in technical textiles, and scope is very vast in automobile, agrotech, protech, mobitech, pettech, mobile tech, geotech, industrial technology, and sport tech. So I will not discuss on this subject much, but these Rapier looms, even soldier machine, they are very much involved to produce technical fabrics of different variety. I will show you next slides. These are the aramid fiber and carbon fiber weaving. You see, this is the carbon fiber which is used in aeronautics, automobiles, sports, and many places. So what weave we want, we can just put a micropulse here. What web we want, we can insert here. Then they are coming directly krill to loom backside. They are take up and fabrics comes on the matching. Same way aramid we can use the beam. Then this is coming on the cloth roll form. So if we see everybody is familiar with the text, linear and count. But if we are talking about the carbon fiber, there is K. 1K carbon, 3K carbon, 6K carbon, 12K carbon, 24K carbon, 50K carbon. So what is K? K means number of fibers. Suppose 1K, there are 1000 fibers in the yarn. Suppose 12K, there are 12,000 fibers in the yarn. So definitely 1K is suppose 600 denier. So everyone knows the denier actually in weaving. And 50K is the 29,700 denier. In this way, 1K is finest and 50K is the coarse fabric, coarse yarn. What fabric will make for final weaving, we can use 1K, 3K, 6K. And for industrial use, commercial use, building technology, we will use 24K, 50K like this, coarse counts. Now we are making glass fabric also. We can make glass fiber, or we can keep glass roving of different denier text. Suppose this denier loom, we are making the PPGL fabric. So in bar there is polyester and weft insertion is in rapier by glass. So consequently the fabric woven, if we just give it heating 100 degree centigrade temperature on currently roller, polypropylene will melt but glass will not melt. They will mesh up and this sheet will make the containers for storage of the hazard gases, hazard acids, etc. They are very much demanded in the market and many companies are making it. Now come to the lino fabrics. Lino fabric means perforated fabrics. It may be in square form, say 10 by 10 into 10 mm lino, or 12 into 12 mm lino, or 16 to 16 mm lino, even rectangle form like 10 by 12 mm fabric, like 10 by 16 mm fabric, depends upon the user's wish. Suppose we are using, I'm telling you what size you can wear after some time, but the thing is that if we make the lino fabric by polyester, this is the baking cloth for the carpet industry. But same way, if we make the lino fabric glass by glass, glass in bar, glass in weft, this is used in geo. We can put in roads, bridges. So suppose we are putting this on tiles, we have to fill up in the slots epoxy. So it depends how much epoxy we want to apply. Suppose we want to apply less epoxy, we will take 10 by 10 mm. Suppose we want to put more epoxy, we will take 60 mm by 60 mm. Like this. This is the criteria of the deciding size of the lino. Now same way you see here, symmetrical width of the glass fabric they are making in 3 width. If they make in 1 width, machine capacity will be only 33%. If they make 1 or 2 width together with the same weaving cycle, machine utilization will be 66%. And if we take this 3 width, there is a 99%. 1% I left because there are the gaps. and some mechanisms are involved here. So we cannot, even if we take the only one full width for owing fabric like this, still there's a small mechanism takes place. So we are getting 99.5% of the width utilization, not 100. Then I'm coming on the water jet looms. Initially, water jet looms were available in the Japan. Nissan company made it, but there were so many manufacturing lacunas, so these looms were not successful. Then Sudokama made the water jet loom. Around 25 years back, Reliance Industries in Ahmedabad taken this project of installing 300 water jet looms for the type polyester was very much famous for saris and dress material. So they have taken the Dobby designs, and a revolution has come in the market when Reliance made these water jet saris in early 80s. The Suela market is still working on these machines, being cost is economic, and the machine is very simple. There's a pump which gives the water for weft insertion. The throttle valve which changes the water direction for two color weft insertion, and water nozzles are there, obviously. Now this is the Sudokama water jet looms. There is a microprocessor again. So certain informations can be put here. This is the Dobby. Some designs can be put here. Then it is covered by the fiber glass because water spreads. So it should not come up to the weaver or staff of the weaving mill. And here wet cloth comes on the roll. We have to keep the roll for some time. There are dryers which gives the fabric just conditioned shape. It can be used. The water jet loom mechanism, if we say, I told you, basically there is a water supply, then there is a pump which takes the water for weighing. There is a throttle valve which is operated by a cam mechanism. So alternatively, or 2:1 or 3:1 or 3:3, any pattern way, this we have to change the cam. So weft insertion takes place from the package. These are the catch cord yarn which catches the residual weft, and weave takes place in the roll form. Now come to the air jet looms. Air jet looms are the very famous for economic weaving, and lot of fabric can be made on air jet looms, and they are coming very fast everywhere in the world. High demand machines. And in 1958, first air started by Max Babu. Then in India, again first air came in the Reliance Industries in 1983. Then this technology is spread to Surat market, then all over the India. Now here, air needs treatment. The compressed air is a precious air, costly air. So Western should not be there actually. So this weft yarn is inserted by the air jet actually, as I told you. And here lino selvages are made of 1.8 inches or 0.3 centimeter in length. Limiting factor is that these are good for the medium to coarse dinner yarn, but finer yarn, there are provisions we are doing, and you know, because of higher speed, 1000 rpm to 100 rpm, air jet loom needs very good quality of yarn. We cannot run on west yarn like Rapier looms here. If we say air jet looms production parameter, we can calculate the production and we can formulate this formula in the machine. The machine itself is the production. the RPM, revolution per minute, then loom running time. Suppose one has set the shift of 8 hours by 3 shifts a day or 12 hours by 2 shifts a day. That way production can come. Then what pick we are inserting? Picks per inch. How many web threads in the fabric per inch? So when fabrics come forward, these threads converted into meterage by this formula. Everybody knows efficiency is the ratio of output to input. Means suppose we want something 80 100 kg and we are achieving only 80 kg. So efficiency is 80%. So this is the way of calculating efficiency. Then CFM is a very important factor by using air-jet looms, cubic foot per meter. The it gives the fix in 1 lakh unit. Suppose RPM is 900 and loom running hour are 12. So how much total fix will be inserted? This formula can give immediately. Then air consumption also shown on the micropods here, or even air pressure gauges in the shade, loom shade, by kg per centimeter square, or pounds per square inch, or in bar. Conversion, everything is conversion standard. So to maintain economic per meter cost of fabric, compressed air wastage leakage must be controlled by schedule checkup and checklisted. See, checklists are very important to control the parameters in any manufacturing process, not only textiles, everywhere. If we monitor the parameter and we keep a follow-up to check, so we can prevent the many unhappenings. Otherwise, we never know when we are getting end product, what's are coming and we are suffering, or one entrepreneur or industry is suffering. So these looms have a very good control. Limiting factor is that operator should be very talented. Retention should not be there. Retention should not be there. Then supplier should be qualified. They should read, adopt the technology. Analyst should be there who can inform intermittently what is happening, what is not happening, what to do, how to do. So weaving cost will be reduced to a minimum. Now Sudagama Jex air-jet loom with microprocessor based control. These looms are very much minimal in markets. Sudagama air-jet loom. They are also in different models like Sudagama air-jet loom 9100, then Sudagama air-jet loom 9200, then Sudagama air-jet loom Jex N, then Sudagama air-jet loom Jex C. Then initially they are coming JW 205, 209, 209 still people are using. So these are the basic machines of the Sudagama Japan. And Toyota machines are coming earlier, Toyota 710 model, now it is 810 model. And mostly denim industry, shirting industry are using these machines for high speed as well for good quality production, high production. Here is a micropulse here. Here we can see each and everything. How much time operator has taken to run the machine. Suppose there are standards for one warp. If below 1 minute required, he takes 2 minutes. It will be recorded. Same way in Weft. So on the basis of downtime analysis, supervisor of the shed can talk to operator for increasing his performance. Same way, maintenance procedure. Suppose machine are having the schedule. Schedule has come bi-weekly maintenance. It will appear on the machine will run. It will be serious maintenance which must be done machine will stop with the alarm. But if there is an intermittent maintenance, okay, it can be run on running machine or it can run on the by stowing machine, but not very mandatory. So it will show a blink in the running machine. After doing that machine, automatically it will switch off for next frequency or next due on. Then here also we can see the fabric designs. We can change the designs. Suppose we are making samples, we can put even thousands of sample here. And earlier it was in conventional way. Once you change lattice, then again changing paper card, then again change lattice, again changing paper card, making the 1,000 sample in a month. Now 1,000 sample in 5 days is possible on this machine, thanks to microprocessor controlled by Japan. So this is a very big achievement. These are the Weft states. We can run 4, 6, 8 colors at a time in horizontal direction. In warping, we can put the colors, different colors of thread by section warping. So checks are possible, stripes are possible in colors, in counts means different types of yarn. Then Picanol AIZ loom from Belgium is the most advantage loom, most modern machine. I'll tell you in later next slide. This is the Picanol AIZ loom. I mentioned here economic viewing. See what is happening in the pseudocomma. There are some small lacuna. Now they are covered up in next models, but earlier there are some lacunas. Suppose air is going, so somewhere air also wasting. So if 30 cfm air is required, instead of 35 cfm air was going, so wastage was there. In Picanol machine, airjet machine of Belgium, they have totally controlled this wastage of air. Now only air will come as and when required in particular mechanism. There is no wastage. So suppose Sudocomma was taking 35 cfm, it is taking only 20 cfm. Initial investment in terms of money is more, but longer time use it is very economic as compared to Sudocomma. Now Toyota AI2 is the air evergreen machine. Toyota 710 and Toyota 810. These are easier machine, and any people can adopt the technology. See, for these textile machines, training is very important, and institute like IMTS, Atira, Nitra, Bitra, Citra, they can give the good guidance to the workers, and they can make very good cultured worker within short duration. So production and quality of the fabric will remain constant. Now, as I told you, multiphase weaving. Multiphase weaving machine is for the industrial use, and here suppose in single phase weaving, as I told you, projectile weaving, rapier weaving, then airjet weaving, then waterjet weaving. Here single weaving cycle, single shed takes place, while in multiphase weaving, many weft cycles takes place in single phase of the weaving. That's why it is called as multiphase weaving. These are the examples of the multiphase weaving. They are very big circular fabric. We are making these awnings and tents by this process. Then multi-axial weaving machine. Multi-axial weaving is utilized for the composite applications. So here different structure of fabric can be joined, and they are used for the composite application. For example, we have to take multi-axial aramid for bulletproofing. So we'll make the multi-axial aramid on the loom. Then we do a further process of the lamination with increase some GSM by putting chemicals, then bulletproofing can be done. Bulletproofing cannot be on the linear fabrics, but it can on the biaxial fabrics or technical fabrics. These are two types of fabric made on multiphase weaving. One is for the combined application where carbon and polyester. Usually we take carbon, glass, aramid, spectra, dynama, any fabric or technical textiles. But joining we are doing by the polyester. The polyester has a tendency to give good knots in the fabric and good strength to the fabric. It doesn't melt in the further process, even at high temperature. Other is the apparel fabric, this is for decoration fabric, curtains and other things. Now Dornier weaving machine with embroidery. Earlier embroidery was different, weaving was different, but Dornier from Germany has brought revolution by making the common machine. So as per the requirement, here they are doing the embroidery, here they are doing the weaving. So these machines are also very much coming in the market, but they are rare. But for composite application, demand is there. Suppose carbon is very costly, DuPont carbon, or Teijin carbon, for especially used in aeronautics industry. Niche customers are there. So to reduce the price of carbon, we are doing the blending. We are making hybrid fabric by putting some glass. So embroidery are doing with this carbon. So because of this, what is the requirement of carbon? We are putting by embroidery. Then to join it, we are doing the weaving with the other cheaper yarn. So that way cost control is there. Now, if you see, this is the narrow rope machine. This made in the Switzerland by Zuckermüller. Now there are many in the India. Even some local manufacturers also making these machines, indigenous machines, and they are in use. Earlier concept of rope was braiding, like 3 or more threads inserted together in a form, and braiding takes place. Now this is weaving. The much advantage of this is that there is a provision for core and rope. Core is inside and rope is outside. So suppose we want to make the carbon rope. We will take the carbon inside, and we cannot hold it by the naked hands because carbon is not good for health or our hands. So we'll put the polyester or cotton on the outside. We will hold it. So sheath, like onion, see, inside and outside layers. So strength of the rope will come because of the carbon core, and aesthetic properties, feeling, handling will come because of the sheath yarn, say cotton. So there is a much use of this application, mainly in DRDOs, space application centers, aeronautics, even ship industry. Ropes are there, and one very big company, Garvai Ropes, are doing a lot of innovation by these machines in India. Now, same way, the other wing belt of narrow machine, again made by the Swiss technology. Zuckermüller is the company, same as the rope. These are the small machines. We are making the small warping beams here, putting the beams here. Then same way the loom, narrow loom, fabric is coming here. Up to 300 meter white fabric can be worn on these machines. Fabric thickness up to 10 mm, belt we can say. Then machine speed 1 to 6 meters per minute. A material can be used cotton, high density polyester, aramid. Even people are converted to carbon for some use in the construction technology. Now on Jacob Muller machine, initially IMTS and Atira taken some projects. jointly to give the awareness of this technology. One is development of high strength core and sheath rope using weaving technology. So we made the ropes from carbon, aramid, glass, and given to the concerned users. And results are very good. In conventional rope, suppose we are using a rope of 10 mm dia by aramid, only 2 mm dia will serve the same purpose. So this is the advantage. Then development of extra heavy duty industrial belt weavings. This mainly for DRDOs, ADRD defense, and even now with this treatment of the lamination coating, they are widely used for the ring frame belts, commercial belts, and other uses. You can see this three-dimensional fabric, which is widely used for the composite applications, as I told you, made on the loom. These are the 3D fabrics. Now 3D weaving is still in progressive stage in the India. Like Stolly adopted this technology in India. They are making 3D fabrics. Technology is complicated right now because it is not well adopted. Even demand is very rare actually. So these technologies are in the progressive stage, but we are using it. Now, if we conclude this lecture based upon the modern method of insertion, we can say selection of loom depends upon the textile material to be woven. Suppose we want to make shooting fabric of trouser, so we will not go for 230 inches wide width. We will take just 73 inches width, or we can take 130 inches width with one split or two split fabric can be made. Depends upon the what entrepreneur can afford to install the plant as well as demand of the market. Then furthermore, versatility of the machine is a very important factor to decide the purchase of loom. Because today, suppose we are running the cotton, a market demand is less now, supply to demand ratio. So he has to change. You know, today in present era, fashion is being changed every day. Every day, customer want a new type of product. So proportionally, we have to go on the machine loom, which is versatile to adopt many yarns. One manufacturer or entrepreneur cannot afford the machines again and again to run the varieties of yarn. So they will think before purchasing or installing the project what can be used for making maximum products in our area to fulfill customer demands. The other factor is that mostly our looms are equipped with the microprocessor controls. A limiting factor is that how much analysis and timely action we are taking on it. If microprocessors are giving information and just be satisfied, okay, run the loom, reset the machine, so machine will come in the hand one day. There is no meaning of investing money for so sophisticated processes. So there must be talented, well-educated, graduate and postgraduate person who handle the machine at the key positions. Even labor should also be talented to operate the machine. This 7th class, 8th class pass labor cannot give the proper way if they cannot read and understand the basic things. So for this type of modern machines, and where one entrepreneur invests so much money, labor is also required qualified. Now, if we see as I told you in the beginning of the lecture, maintenance is very important. If we do maintenance in time, machine will always remain with us. But if we avoid maintenance, machine will also avoid our demands. So suppose we are giving good treatment to machine, we are following all the process of daily checking, bi-weekly, weekly, quarterly, like this. We are changing oil in time, we are putting grease in time, we are taking specified oils. So question doesn't arise, machine will remain always as new and will give the very good efficiency and productivity. Even 40 years old machine, 50 years old machine, if we are updating every time, keeping in mind good maintenance, it will remain as new machine actually. But if somebody will install new machine, but if they will not consider the maintenance, there must be deterioration in the performance and productivity. So this is the heart of the process. We should keep focus on these 4 points. Number one, what machine should be purchased or installed, what quality should be made, then microprocessor awareness, qualified staff and workers in the company, then maintenance. Now, thanks for this, and this session is over. If somebody has a question, please you can ask. Thanks.